Okay, well, I guess we'll just go into examples. First derivative test. Use the first derivative test to determine the local extreme values of the function and identify any absolute extrema. Support your answer graphically. We're not doing that part.
Yeah.
Y equals negative 2x cubed plus 6x squared minus 3. All right, so we...
LEX? Or
6x?
6x?
I thought that was X. So I was like,
Ellie is not. Wait, that's not saying it. No.
6X.
Okay.
All right, so the derivative of that is...
Negative 6x squared plus 12x.
So we set it equal to 0 and find the zeros. So how do I do that?
Factor.
Okay, well, let's take
Factor
out
what?
Let's take out
The number.
we can take a 6 and an X out. Negative 6X. X minus 2. Break them up. Negative 6X.
X equals 0, X equals 2.
All right, so now the difference is we're going to set up a little sign chart. Now remember, this is going to be the sign of y prime. So we're plugging these numbers and these intervals into the derivative. So if I put in negative 1 up here, what happens? And I don't care what the number is, I just care if it's positive or negative.
Positive.
Are you sure?
It'd be
Not
a
sure.
negative.
Actually,
It'd be a positive
negative.
6
Yeah, it'd be
minus
negative.
12, which if you did that calculation, it would give you negative 6.
Good job.
So I'm just putting the numbers down here that we're plugging in just for reference, but you don't have to do that. All right, in between, if I plug in a positive 1,
I think you would still
Default
get a
to
positive.
gonna get a positive,
Just 12 greater than 6.
and 3.
If you did this, like it would definitely be
Wait, what?
He said it was definitely gonna be, and then he stopped.
negative.
Negative.
Yeah, I was like, wait.
Because if you like really think about it,
All right, so if we go from negative to positive, what is 0? Is it a min or a max?
Matt, min,
Okay, so there's a local min
7 min.
at x equals 0, and we'll find what the actual point is in a minute. And then there is what happens when we go from positive to negative?
Max.
Max.
A max. So we have a local max at x equals 2. And then we take these numbers and plug them into the original to get the point. So f of 0. So if we plug in 0, we get
0. Oh, original. Negative 3.
negative 3. So that point is 0, negative 3. So there's a min at the point 0, negative 3. What if I plug in 2 to the original?
Okay, so
Let's think about it.
Equals 0. I mean, wait.
I'm getting
12
5
times 12 and wait.
or
So negative 16
negative 11.
I missed
plus
it.
24 minus 3.
Wait,
I'm getting
Oh,
6.
the original.
I'm getting 6.
getting-
I was doing the
9.
derivative. My bad.
9.
I'm getting 6.
Well, if you plug it, if you were wondering, if you plug it into the derivative, it's 0.
Wait.
That's why it was a 0.
5.
What's the
Hmm?
That's why it was a 0.
That's why what was 0?
Yo, I low-key got
0 and 2 were zeros. So if you plug it back in, the function should be equal to 0.
I'm getting 5.
That
Huh?
makes sense.
5.
5 is what it should be.
Okay,
Oh,
so
math
that was my
and
first answer, but then I went through like 7 different answers. and got that.
Yeah, I was a little confused on what was happening.
I was just doing the totally wrong thing. I was just like in my own little world.
Like, we'll get there eventually.
All right, and for these, they do want the point, not just the location of it. Like, they want it like that.
So if it just said like find the local min and local max, you wouldn't have to do the point. Like what in the direction makes you have to do the point? Like does it say
Pretty much always do the point.
just always? Okay.
We had a couple problems that just said, like, that there was a min at x equals 0 back in 5.1, but pretty much now you're always going to be doing the point.
Okay.
And pretty much the only reason that I would say you won't need to do that is if it's a multiple choice question and it asks for an
Oh.
x equals value instead of a point. But
Yeah.
if you have the option to write it as a point, write it as a point. All right. Let's throw it back a little bit. Y equals x e to the 1 over x.
Ooh, okay.
Okay.
I didn't-
Ethan, control your classmates.
I didn't use the ones.
Dude.
What I do.
I said control your classmates.
I am confused.
No, you're not.
I didn't laugh.
We're like having a long conversation on the back row over there.
Nathan, not. Nathan, not.
Nate was making me laugh. Nate.
Yeah, thank you.
Just like you do on the basketball court. Calm down.
Yeah.
It's like my favorite part of the game when people get a little crazy and Ethan runs over and he's like, no,
Riley does that to me.
chill it down.
If I get mad, Riley's like, no. And I'm like, okay. I'm like, thank you, Riley.
Ah, come
Oh
back.
my goodness. This is so cool.
All right, what's the derivative of this?
What's cool?
Nathan must have already solved it.
E to the 1 over x. Because it cancels out.
Okay. Well, what is this?
It's a linear.
It's a
What's the next?
chain rule.
Oh wait, it's a
Well, that's part of it. It's also a
cost. What? Exponential cost.
Adding.
a piece times a piece is a
Product.
product rule.
Oh, I was like, what?
Oh.
You have done one part of the product rule. Plus, what's the other part?
Nathan, no.
It's just whistling his favorite song.
X times
Ew.
e to the 1 over x times
Can you stop it? Like, no. It's not very tiny.
Need the derivative of 1 over x.
it's like
The derivative
oh
of
my
one
gosh.
Think of it as this. What's the
negative
derivative of
x
that?
To the negative 2.
Literally, yeah.
Literally, yes.
What are
We can't do this.
we? Wait, what are we thinking of that as? Wait, oh, like the 1 over x?
The 1 over x part as x to the negative 1.
Okay.
What is happening?
So you know.
All right. So, this is going to be reduced to e to the 1 over x minus e to the 1 over x over x. Now, something that you might not be aware of that you can do, we can take out an e to the 1 over x because it's in
No
both
way.
pieces and leave us with 1 minus 1 over x.
Nice.
This is where you'd probably be sad if you had to take the second derivative of this function, but we don't have to do that because
Yay.
we have this lovely first derivative test.
I love the first
Hey,
derivative
I don't
test.
like being sad. I'm already sad, so I don't want to be more sad.
Why are you sad?
Why are you sad?
I'm so sad. Literally, English makes me sad.
Oh, the
What is
paper.
his name?
Yes, I want to kill myself because of English. I won't let English destroy me. Because it already is, but
English is not fine.
literally is. Like my parents will
That was
probably
beautiful.
destroy me.
That was beautiful.
if
Thank
I
you.
don't do this.
English is
Take
only
Spanish then.
temporary, Josh.
Spanish is so much easier than English. Being so for real.
Well, because it's the beginning of the language. We're in the advancements of the English language,
Like I don't care.
like verbs.
All right, what values make this 0?
None.
One.
0?
1.
1?
No.
Are there any others?
Oh yeah, 1 minus 1. No, because 0 would make it under.
No, that's all I'm getting.
All right. What else would cause a problem?
If
Zero would.
0.
0 would.
why would that cause a
Well,
problem?
wouldn't it would be undefined.
Oh.
Silly.
And then I would have e to the undefined, and we can't have that either. So that would also cause a problem. So we include that in here as well. But that doesn't mean there's a min or a max there. It just means it's a point of, like, interest, kind of. Okay, because we can't have a min or a max where there's not anything, because it would not be continuous there. That's a point of discontinuity.
Wait, which one? The 1?
This one,
Oh, that one.
0, because it causes
So
an
it's not
undefined
so that
situation.
wouldn't be a min or
So we're gonna use it. We're gonna use it to find in the signs. Yeah, I'm good. To find the signs, but it's not gonna be included as a min or a max.
Oh, okay. Because it technically doesn't work.
Correct. Because it's an asymptote there.
It's gone.
What is happening back there?
My jacket fell out.
so silly.
Your jacket fell out?
Mm-hmm.
Oh,
Yeah.
your what?
The string.
The aglet, not the aglet.
No, the entire thing, the entire jacket, Josh.
No, that's
Wait, so between the 0 and the 1, are you gonna put like, what, half or something?
Yeah. Unfortunately. All right.
Unfortunately.
Now, remember, we're going into the derivative, so it's going here. So, -1.
What do we?
Into the derivative.
Positive.
Positive. 1/2.
What do we make it negative?
Huh?
Are you guys playing it? Wait, Josh, are you playing into this or this?
The derivative.
This.
Yeah, okay, just making sure. That's what I thought.
What do we?
Yeah, I don't know how, but I don't even know how. I'm confused how you would even like plug up.
So wouldn't you like put the fraction in and then like flip it, kind of, because it's.
So then this would just become e to the 2 times 1 minus, flip that over 2. Which is a negative and a positive, so it's going to be negative. And 2.
What do we positive?
What do we want yours on?
What do we what?
Alright, now remember, there can't be a min or a max here because this is an asymptote, so the only one I'm actually looking at is x equals 1. So, negative to positive is a
Min. Min.
So there's a min at x equals 1. So f of 1. So if we plug 1 into the original, we get
E. Wait. X E.
No, it's just E.
The X is
e.
one.
X is 1.
Oh. Very hot.
I was like,
I was like, the point of that was to not have an
I
X.
forgot. This is great.
I did not like that problem. Not one bit.
I thought it was cute.
Yeah.
It was not cute.
Interesting.
Tried to be cute.
It's not my type.
All right,
No, it's not your type, Nathan.
concavity test.
Ew.
I forgot how to do this.
All right. Use the concavity test to determine the intervals on which the graph of the function is concave up or concave down.
Oh, this one's second derivative.
Yes, it is.
Goodness gracious.
Y equals negative x to the fourth plus x cubed minus 4x plus
Okay,
1.
That's not terrible.
Well, they always trick you with the easy ones.
But then in the homework, they give you like.
For real.
I was so, in the homework. I was so excited to get to the antiderivative part, and then the first one was f derivative x equals x,
And I got
and I was
stumped
like,
with it.
how do you get back from x? Like that was crazy to me.
It was
1/2 x squared.
It said the answer in the back of the book said yeah.
Oh, speaking
Or
of
x
that-
squared over 2. They might have written it that
I
way.
was just like, how do I even?
Oh, speaking of that, I have my homework for you to show you.
Okay.
Do you want to see it from here? There's also a little bit.
Well,
of
I need
that.
help with homework. I need help with the problem.
Homework is
before it's done, but I need 11. It's the word problem.
To find that she was speeding.
Ethan's like, what are they holding up? They're holding up the last section of homework.
Huh?
They were holding up the last section of homework.
Oh.
Okay.
Anyway.
First derivative.
Okay. Negative 4x cubed plus 3x squared minus 4.
Getting a little speedy there. All right, second derivative.
Okay. Okay. Right.
Don't get crazy.
Negative 12x squared plus 6x.
3x.
Wait.
Got it! Got him!
He's getting
Wow, what an accomplishment.
I know, I'm proud of myself. Zons.
Sounds crazy.
Zons.
Oh. I wrote the problem sort of wrong.
Oh,
There's
no.
supposed to be a 4 right here.
What do you mean?
No.
So this is
What do you mean?
gonna be a 12.
Zons is saying-
And this is gonna be a 24.
I'm so-
Who let this is crazy?
What?
I know this one works out nicely. I'm not sure that the problem I wrote was gonna work out nicely, so I was like, we better fix
Okay,
that.
that one.
Oh, it does look nicely.
It looks a little better now.
Oh,
I was like, I don't know if the zeros were gonna be pretty or not, and the other ones I was like,
Okay, so are we gonna equal 0 with the second derivative?
yep.
Okay. So let's take out a
I thought
negative
that's
12x.
I'm still writing.
Oh,
I was
you have
about-
to
I was
write
about
those
to
equal
add.
0. What do you mean?
But I added another line for that.
Look at that. That's so good. Because
Thanks.
x equals 0,
I do my
x
best.
equals 2.
Oh, that's way better.
Wait a minute. It's the same. It's the same.
Well,
So now
at
we
least
gotta
it's
plug
not.
it.
It's
So
this is
now we
not
gotta
0
plug
and
it.
1, so we don't have to do 1/2.
For real.
This is basically the same thing.
All right, now, what is this getting plugged into?
Second derivative.
Second derivative. All right. So negative 1 into the second derivative.
How do you do that so quickly?
What did you say?
It says don't get crazy.
Into the second derivative?
No,
It's
you just
not
want-
positive. It's not. Wait. It's negative.
Let's put a negative
Oh.
one in there.
It's definitely.
That's why I was like, hold up.
No, I was really
I
like.
thought you were saying that
what
for
do you
Nathan's
mean?
thumbs. And
I
I was like, what did you say? I was like, wait.
Okay, no, the next one is positive.
Are you sure?
Let's throw
Yeah.
one in there, right?
Yep,
Right?
throw that
Let's
one in there.
Caps on.
Or what?
I don't think it counts.
It'd be positive. Alright, now let's throw a 3 in there. Can't see it.
Good choice.
Get your piece of
gonna be.
So we can put. It'd be
It's negative.
It's like,
What is 9 times 12? 108.
108. It's negative, Josh.
All right, so now
In your head.
I need to see where it is concave up and concave down.
Whatever that way.
Oh, 0 is concave up.
You know that how.
Because it's going positive, right? Because if it's increasing, or. No?
You do the test of concavity.
Be confident, Peyton.
I don't know.
Concave up on any interval where y prime is greater than 0.
Oh.
So if it's positive,
It's
so these are interval values,
Oh, I was reading the
not points.
concave up and down. Oh. Open. Wait,
So-
what?
So if y double
Increasing
prime
on
is
I.
greater than 0, so if the
That
value
must
in
be
here is positive, then it is concave up. So this would be from 0 to 2.
Wait. Where is it? Y is greater than 0.
So then concave down
Okay, I
would
missed it.
be negative
I was
infinity to 0.
Union
I was reading the wrong
to
thing.
infinity.
So they don't write union, they just write and. Just, oh no,
Really
it doesn't.
complicated.
Well, normally we have written that, but they just write. They do it as an and. And notice they're all open. These intervals are open intervals.
Why are they all open? So they don't.
They just are.
Oh.
I think it's because it's a 0, so it's where it's changing direction. It changes
Okay.
concavity at that point, so it can't be.
You can't. Yeah.
It can't be concave up and concave down at the same time.
Okay.
I think is why, but I don't know.
I remember the day when parentheses were just parentheses.
Real.
Um,
didn't know what a
let's
bracket was.
see.
Yeah.
10.
Oh, she really threw us a curveball with those cinnamons.
Cinnamon,
I definitely-
cinnamons?
I definitely
Cinnamons?
messed that one of you.
The synonyms and
The synonyms, yeah. And I was like, I'm prepared for
Cinnamon.
it.
She gave us synonyms on our quiz.
And
Were they all synonyms?
No, they were
synonyms
all
and were
synonyms.
like 5
We used to have
synonyms.
synonyms and antonyms on all of our quizzes.
That's awful.
And I was like,
I wasn't ready for the synonyms.
was
I
rude.
messed up on
kind
them.
of messed up my flow.
It did mess up my flow. Like I was.
I knew all the
alright, but-
antonyms.
I think I got the synonyms right,
To
but
be honest, I don't even know where my head was at when I quiz.
Alright, concavity test again.
Alright, let's go with. So, first derivative. Negative 1/3 x to the negative 2/3.
Ugh.
Oh gosh. Okay. So it would be 3/9. Oh, can we reduce that?
What?
Wait.
3/9.
Wait.
How about 2/9?
Oh,
2
2/9.
Positive 2/9.
I was like, wait, did you add but then multiply? You added?
You add it on top and multiply it on the bottom.
That's a new type of math.
To the negative 1
To the
5/3.
-5/3.
Yeah.
Whoa.
That's easier to do.
Man, this math problem is.
This stuff is throwback from chapter 3,
Well, like I
and
was
we are
gonna say,
struggling.
I was gonna say 1
It's the
1 and
fractions.
2/3, but
The fractions are
Fractions are not that.
The fractions are not.
they're no.
That's the thing. The class that I have in Algebra 2 right now, I feel like they have the hardest time understanding 2 pi
Oh.
in increments of 2 pi. That like 4 pi over 2 is 2 pi.
Why?
Wait, but
Wish I could
wait,
tell
that
you.
4 pi over 2
It reduces
Like when we're
to
doing
5.
like when we
Yeah,
were
wait,
finding
reduce fractions?
no, like they didn't know how to like make like 2 pi into a fraction that matched the denominator of what they were working with.
You just
Oh.
you basically
Like
just
they couldn't
put
tell
it
you
on
that
5,
like
right?
that like 8 pi over 4 was equal to 2 pi. So when I would say I need something that's pi, some form of pi over 4 that's equivalent to 2 pi, they were like, 3 pi over 4. And I was like, no, it's got to be equal to 2 pi.
I mean, you can kind of just disregard the pi.
I'd be like, take the pi out, okay, in fractions.
Maybe that's what I need to tell them to do. I don't know.
Maybe.
They were
Maybe
like
the pi
so
is-
thoroughly confused,
That
and
would
I was
probably
like,
make it easier.
Maybe the
Just
pi
like,
is confusing them. I don't know.
Don't look at the pi.
Do not look
What
at
if
the
you're
pi.
hungry, though?
How do you
That's not
even,
funny,
like-
Nathan.
What'd he say? What'd he say?
That's like, it's gonna equal something.
Wow.
Let's think about this, right?
Okay.
Let's get
You
the
would,
2 over 9 we can get rid of.
Yeah. Can we
Right.
like change these fractions into something else?
we probably should do this before we do anything else.
Wait, what did you do?
Can you see it?
Yeah.
So I moved
Disgusting.
the x to the negative 5/3 to the bottom
Oh, okay.
because if I leave it there, I could theoretically have an issue. Where might there be an issue?
If x equals 0.
Pi. I mean, disregard this.
At 0.
I love your confidence.
I love it.
Okay, so the only way this is going to be equal to 0 is if x is 0. Now, that causes a problem, but we're just using that to help us determine concavity.
Oh.
So we're still going to use that to determine
I
what's
forgot
happening.
it's not a local min-and-max. So I was like, I was about to be so confident and be like, there's no min or max.
All right, so I need to know sign over here and sign over here of y double prime.
Alright. You really want it.
So if I plug in -1, this is, should be easy,
Negative.
negative. If I plug in 1 over here, it should be
Positive.
positive. So where is it concave up?
Up to
Zero,
0
infinity.
infinity.
And concave down.
Negative infinity 0.
Okay, that one was.
Okay, that one was pretty easy.
I like when it's just.
Okay,
A
like
little
it
trickster.
didn't start off like my type, but like it ended.
Let's see if this next one's your type.
It's math.
Y equals e to the x, 0 less than or equal to x less than or equal to 2 pi.
Yeah, that's the 2 pi. Is that what made you remember? Did you see the 2
No,
pi?
I just, when y'all were talking about the fractions and we're like, can we make this something else? All right, what do I do?
Okay, okay, okay,
Okay. What?
okay.
So the derivative.
Is e to the x.
Is it to the x?
And then second derivative.
Um,
Guess what?
It goes from
C to
x
the x.
to the x.
So
Plus c. Kidding, it's no that section.
now you would
That was last section.
But the antiderivative of e to the x is
one.
E to the x
E
plus
to
c.
the x plus
e to the x plus c.
Oh, what?
What?
All right, now what?
Okay, equal to 0.
Equal to 0.
It doesn't work.
Well, let's think about it.
Oh, that's crazy. So 1 equals
What's
x.
the ln of 0?
X equals 1.
One.
Is it?
No, wait, no.
X equals 0.
ln is
She's
1 over
smart.
x.
She's smart that ass.
So it's 1 over 0. So it'd be 1 over 0. So it'd be on 1? Or did I get that?
Let's
I think you just inverted what I had already done.
Oh.
Let me give the little calculator out
Is it calculated?
because you know given no one.
Oh, I did because I
It
was
doesn't
thinking
work.
It's not.
Doesn't
I was
work.
thinking the derivative of
Told ya.
ln. That was my
I did say so.
Okay, but we're also on this interval, right?
Yes.
Okay. So if I plugged in like an endpoint like e to the 0, e to the 0 is 1. So anywhere in there, this value is going to be positive. Okay.
Oh.
Y double prime is always positive. So what does that mean?
Always up.
So it is concave up.
Nathan.
Oh,
Of course
never
it
knew.
can't be negative. It's always
I mean, he's not wrong.
I was like doing that stuff in college algebra this morning, and like we were reviewing, and I was like, it's either I was like it. I think I said it's alternating or something like that, and then they were like, I don't remember. Anyways, I was like, it's just not it's non-negative. It's like so it's 0 or positive. It's like it's just non-negative.
So it's negative, right? We have 4. Cool.
Okay, I think I'm gonna pause there, but I am gonna go ahead and give you some problems. We'll do points of inflection, which is basically just plugging the numbers that we had from like our second derivative test essentially back into the original and seeing if it's a point of inflection or not. Because it's where the concavity is changing. So if concavity changes, then it's a point of inflection, and we find the point where that occurs. Anyways. So up to this point, you can do 1, 3, 5, 7, and 9.
Nice.
I think this is my favorite section.
I like this. I like.
I feel like we're progressively getting easier. Like we
Yeah.
started out with
I
like the
know.
hard stuff, and then it's gotten a little
Yeah.
easier. But we'll wrap up this section on Tuesday. Quiz Thursday. Quiz Thursday, because we're going out to lunch on Wednesday, so you can't have that. So I think we'll do stats Wednesday instead. So that solved that issue that we were having.